Alrighty guys, welcome to the 7th video in the series. Today I'm going to be finishing up all the financial feature functions. Now we got quite a bit more to cover, and these are the ones we're going to cover today. There's 11 of them. The data resampler, momentum, stochastic, Williams oscillator, price rate of change, accumulation distribution oscillator, the moving average convergence divergence, the commodity channel index, the Bollinger Bands, price averages, and slopes. And I know it seems like a lot, and it really is. So if you guys really want to intimately understand what we're doing, I encourage you guys to try and look these up and do them yourselves. But I know it may be difficult and you want to see the way I did it. So this video, I'm just going to breeze through all of them. And you guys can pause the video when I'm done writing each one. I'm going to fast forward through, and then I'll talk about the key differences between other functions and things to look out for and why I did it a certain way. That being said, let's get started. Alright, so the whole purpose of this function is to resample the data and change the candles to a different time period. So right away you'll notice that I take column as an input, and that's because it depends on which column. If we have tick data, which column do we want to resample into the candles? And usually it's the ask data, so we default to ask. So first off, if we have tick data, then one of the columns will be ask. So that's what you see me doing here. If any of the columns are ask, then we'll do this. And then we'll say if column, which column do we want to resample? So you'll see me setting up each of the cases for if a column is if we want to resample the bid or the ask column. Next, we're setting up the function to handle data that's already in candle format. So if it's already in candle format, we can only resample to a longer time period. We can't go to a lower time period from a higher time period simply because we don't have enough data. So that's what I'm doing here, is just resampling data that's already in candle format, and then I'll be returning the resampled data frame right here. Alright, so that is the completed function. Coming up next, I will show you guys a screenshot. Here's the screenshot. And then next is the setup for the tester. So this is the tester setup, and then the associated data results for that. Alrighty, so this is the momentum function. So the momentum function, again, you'll see me import take prices and periods as an argument, and then here I'm initializing two dictionaries, the open and the closed dictionary, because we can have momentum for both the open and the close. So I'm providing that as an option. Now the momentum here is essentially just the difference between two prices that are a certain distance apart. So that's what I'm doing here, is I'm initializing a data frame inside the open dictionary and the closed dictionary for each period. Now you'll see here that I make a small error, and it takes me a second to figure it out. So if you're watching this, try to just to look it up and understand the main concept of what we're doing. Here coming up soon, I'll be just putting on screen the screenshot of the finished function that is error-free, and that's this right here. So pay attention to that, pause the video on that. This is the setup of the tester function file so that we can get results, and these are the results for the momentum function. The stochastic oscillator is a relatively simple function. There is a little bit of a difference. The main difference being that usually I refer to the current period as J, but in this function we're doing J plus 1 current. And that's because we need to look at a range of data behind us, and that's that J minus periods up to J. So J plus 1 is the current, and you'll see that also reflected in the data frame that I stored in when I do the index. So you always have to make sure that the index is the same. So you'll see me doing here periods plus 1 and then to minus periods plus 1, and then I'm storing it in a data frame as I normally do. Here is a screenshot of the final function, so pause the video on this and take a closer look. Next is a demonstration of the tester.py file, and this is how I achieved these results. Again, just take a pause here and check it out. So you'll see me setting up the Williams %R function, or the Williams oscillator as it's sometimes called, in pretty much exactly the same way as the stochastic oscillator function. It is the exact same in a way that we're doing the current period as j plus 1, and we're looking at a range behind us for a minimum and a maximum value. Again, just like the Williams or the stochastic oscillator, I'm saving all of the data in a data frame that you see me doing here, and remember to create the index similarly to the stochastic oscillator. And that is pretty much it. Here is a screenshot of the finished function, and coming up next I'll show you the tester.py file, and this is how I set up the tester so that I can achieve these results right here in the plotly plot. Okay, so for the price rate of change function, think slope or percent change from one value to another. So what we're going to do is we're going to take the value today and we're going to subtract off the value of yesterday divided by the value of yesterday. So the percent change from yesterday to today. Now be careful when you're writing this one, because you'll see here that I use a line break operator, which is the backslash, and that's right here. So, and then I'm just dividing by the price of yesterday. So this one is extremely simple, and I think we only calculate it for one period, but I set it up to handle multiple periods. So again, here is the finalized function screenshot. It's relatively compact and easy. Next is the tester.py setup, so that if you want to test it out, again, this is the results of that indicator. So the accumulation distribution is not to be confused with the Williams accumulation distribution oscillator, but this one is set up very similarly to the stochastic oscillator and the Williams %R line, in that it's a j plus 1 again. So with the j plus 1, we are looking at today as j plus 1 and a range of time behind us that we're doing j minus periods up to j. Okay, so this is again a relatively simple function, and I'm setting it up in the exact same way. Make sure that your index reflects the j plus 1. Here is the screenshot of the finished function. Again, the setup of tester.py and the associated results in a plotly plot. The MACD, otherwise known as the Moving Average Convergence Divergence, is one of my favorite financial indicators. So it's basically the difference between two exponential moving averages. You'll notice here that our periods input is only a 1x2 array, and it's not a list. So right here you'll see me creating the two exponential moving averages based on those two periods, and then the MACD is simply the difference between those two. We're also going to return a signal, and the signal is just the 3-period moving average of the MACD. So again, here is the finished function, and then additionally the tester.py setup, so that if you want to take a look at what the result is in a plotly plot, that's what it would look like there. The Commodity Channel Index, also known as the CCI, is probably one of the easiest functions that we're doing here. And again, you'll see that I initialize the results class, and I have the dictionary for the results called CCI. I'll change that here in a second. Go look up the formula for CCI. I forget exactly what it represents, but I will link in the description to Investopedia or some other website that explains it in depth. Again, here is the finished function screenshot. Take a pause and a deeper look, and the tester.py setup. This is the setup to achieve the Plotly table or Plotly graph that looks like this. Bollinger Bands. Everyone knows Bollinger Bands. So Bollinger Bands is just going to plot two lines, an upper and a lower, also a middle line, representing the lines of certain standard deviation, rolling standard deviation from the rolling mean. So that's what I'm doing here is I calculate the standard deviations. We also accept deviations as an input, so I think usually I do 2 deviations, but I set it up so you can change it for whatever you like later on. Again, here's the finished function screenshot. Additionally, the tester.py setup to achieve the Plotly results, again, right here if you want to take a look. The price averages function is literally the easiest one on this list. All we're going to do is calculate the rolling mean of all of the OHLC data, every single column for a given period, and save it again in a dictionary in a data frame. So you see me doing that here. I select the entire, all of the columns right here, open, high, low, and close, and we just get the rolling mean for that period. Super simple again, and here is the finished function screenshot. If you want to get the tester set up, this is how it should look, and this is how the data should look in the Plotly plot. Alright, so for the slope function, what we're trying to do is take a certain range of data and fit a linear regression line to that window of data and then get the slope from it and save that slope. So it's relatively simple. Again, it's going to be a double loop function, and you see here that I'm initializing a list called m's, and that's just m's meaning m in y equals mx plus b. I initialize the y data as the price range that we're looking at, and then I use the stats linear regress function to get the slope and save it again in a data frame with the correct index. And I'm doing it for the high column, and that's just because in the research paper that's what they specified. I'm not doing it for close or anything. Again, here is the finished function. The setup for tester.py is right here, and the Plotly results are right here. And that was the last function. Jesus, and there is all of the functions. Thank the Lord, right? Amen. We are finished with the financial functions. What is it? 725 lines later. So I hope you guys got through this. It was extremely boring. This is like the most boring part of the series. Next, we're going to be doing the machine learning, arranging these features, doing some data pre-processing. So we're going to get into the more interesting and more technical aspect of it all. And so I just want to thank you guys if you've sticked around this far. Thanks a lot for watching. Go ahead and subscribe if you want to. And leave a comment if you have any questions or if I messed anything up. I will quickly rectify that as soon as I can. I've enjoyed making this series so far, and I'm excited to make the upcoming videos, so stick around.